Okay, so here we are in our final exam review. And so this sheet is for units D and E. Now, unit D was hopefully simple for us. It's the unit that most of us did pretty well with. And unit E was fairly short. So we're just going to combine the two together. If you need more review on either of these two units, check out the other review that we have done for these. But we start talking about matrices and just some basic operations here. So don't forget, when we are subtracting or adding matrices, we have to have the exact same dimensions. And so this might be a very interesting video because I am now realizing that my writing board is very, very sensitive for some reason. So my handwriting might be exceptionally sloppy today. But let's go through this. So we have 4 minus a negative 1, which is going to be 5. We have 4 minus a negative 5, which is going to be 9. And we have a negative 2 minus 1, which is a negative 3. And so that gives us our answer there. Notice the same dimensions. Over here, we're going to have a negative 4 plus negative 6, which is a negative 10. We have a 5 plus negative 2, which is 3. And we have a 2 plus a negative 5, which is a negative 3. So like I said, adding, subtracting, make sure that the dimensions are the same, and you just add the corresponding positions, or subtract the corresponding positions. Next up, this is called scalar multiplication. And so what we do is basically distribute. So a scalar is just some number, and when we have scalar multiplication, we multiply that number times each value in the matrix. So if we have 2, negative 5, negative 2, we distribute in this negative 4. So this becomes negative 8, 20, 8. Simple enough, right? Same thing over here for number 4. We have a scalar of negative 3, and so we are going to distribute that in. So we get 12, negative 18, 6, negative 9, negative 9, and negative 6. There we go. Then we move on to multiplying matrices. To multiply matrices, we have to have the rows and columns match. So the columns in the first matrix must match the rows in the second one. So this is a 3 by 1 matrix, and this is a 1 by 2 matrix. So we can actually multiply, and we're going to get a 3 by 2 matrix. So we're actually going to get a larger matrix here. So this is going to be a 1 times 0. So 1 times 0. So we multiply each row by each column. So there's actually not going to be any addition here, which is weird because it's just one term here. So 1 times 0, and then the next term is going to be 1 times negative 2. And we can see my rows there. 2 times 0, so 2 times 0. And then next, 2 times negative 2. Whoops. Next up, we have a 6 times 0, and then a 6 times negative 2. So I'm actually going to cheat a little bit here. I guess I'll just try to fit this in. So my 3 by 2 matrix is going to be 0. Actually, I'll write it up above. And I'll change my color. So usually I'll resize these worksheets when I make your videos. I did not this time, and I'm suffering for it. So we get 0, negative 2, 0, negative 4, 0, negative 12. And that is our final answer for number 5. For number 6, we want to do the exact same multiplication. So we want to multiply each row by each column. So this is a 2 by 3, and this is a 3 by 2. So we can in fact multiply, and we will get a 2 by 2 as our product. So we do a 2 times 2 plus negative 5 times negative 1, negative 1. Negative 1 plus negative 6 times 3. Really, I have no room to work with this, so I'll put this down here. Because that is our first digit. The next is going to be a oh, sorry, this is a 3 by 1, so we'll have a 2 by 1. So there are no more columns, so I'm done here. So then this is going to be a negative 4 times negative 1 plus negative 3 times negative 1. Whoops, sorry. This is a negative 4 times 2. So negative 4 times 2 plus negative 3 times negative 1 plus negative 2 times 3. So that gives us our 2 by 1 matrix, which, in looking at all this, we get a 4 plus 5, which is 9. And we do that. 9 plus a negative 18 is going to give us a negative 9. And we have a negative 8 plus 3. So negative 8 plus 3 is negative 5. Plus a negative 6. So negative 5 plus 6 is negative 11. And that's our answer there. So we could use this in a calculator, but hopefully this is simple enough as long as you're catching your mistakes like I'm catching mine. But it's each row times each column. So when we had our test review and other problems that we did for these, we did some really monstrous, like I believe we multiplied a 5 by 4 times a 4 by 3 at one point, which is really good practice, and it really helps the procedure get down. Don't forget, for your midterm exam, just like the test, I am going to need to see work to make sure that you can actually work all this out. Now we want to find the determinants for these. So finding the determinant of a 2 by 2 matrix is hopefully simple enough. It's just going to be AD minus CB. It's that cross product. So 1 times negative 1 minus 2 times 3. So this is negative 1 minus 6, which is negative 7. What sometimes people do is they confuse because the inverse is 1 over the determinant, and so here they'll say, oh, the determinant's negative 1/7. No, the determinant is this number. It's the whole number there. Likewise, for number 8, we have a 4 times negative 1 minus a negative 4 times a negative 3. So simplifying this, I get negative 4 minus a positive 12. Watch out for your negatives. Put things in parentheses and really write out each step so you catch that this is minus 12, so we get a negative 16 as our answer. Now to find the determinant of a 3 by 3 matrix is a little bit more involved, but what we're going to do is we're going to have the first value in each column times a special matrix. So this is 5 times, well, if I get rid of everything in the same row and same column, I get 2, 3, negative 1, 0. And I'm going to find the determinant of that small matrix. Next, I'm going to subtract, I'm going to look at 4 times the determinant of some small matrix. Well, if I get rid of everything in the same row and same column, I get 3, 3, 0, 0. And I'm going to add now this value, so 1, times the determinant of a special matrix. So 3, 2, so 3, 2, 0, negative 1. So this is going to be a 5 times This is 2 minus a, sorry, 2. That's 0. So 0 minus a negative 3 is positive 3. Minus 4 times, well, that's 0 minus 0, which is 0. Plus 1 times negative 3 minus 0, which is negative 3. So we actually get 15 minus 3, which is 12. What I really recommend you to do is to work through this by hand, but then go and check this in your calculator. You know, something like this your calculator can easily do, so there's really no reason to get this wrong. And I say that fully knowing I'm not going to check this in my calculator right now, so I really hope this is the correct answer and I didn't make a mistake. But if I did make a mistake, let me know. Or check it in your calculator and show. If you're looking at this worksheet, the answers are posted attached to this. I don't have them here, but you can easily see that. Same with this next one, so we're going to have the first values in each column times special determinants. So I look at 4, and I get rid of the same values in the same row and column. So I get negative 4, negative 1, negative 3, and 5. Let's try and make that a little bit clearer. So negative 4, I don't know, it's not 9. Negative 4, negative 1, negative 3, 5. Good. And then we're going to subtract another value. Now that value is a negative 3, so I'm subtracting a negative 3. And it's times the determinant of some matrix. Well, that is 0, negative 1, negative 1, and 5. Looks like I don't know. Better. Plus, and this is going to be an easy one because it's plus 0 times some matrix, right? So that would actually be 0, negative 4. This is not as easy as it looks. Negative 4, negative 1, and negative 3. Hooray. So we get 4. Just wants to be 9. So 4 times, this is negative 20 minus a negative 3, so that's plus 3. Sorry, it's negative 20 minus a positive 3. Negative 20 minus a positive 3 is negative 23. Plus 3 times, that's 0 minus 1. So that's negative 1 and plus 0. So 4 times negative 23 is going to be negative 92, I believe. Right? 12, yeah. Minus 3, so that is negative 95. And so that is our answer there. So, you know, something to watch out for with all this. Make sure that you are doing everything, you know this procedure and you can do it all well. Now to find the inverse of a matrix, we're going to need our determinant, but there is a special formula here. So this is 1 over AD minus BC times the determinant of D negative B negative CA. So after I get the determinant, I actually have these values. So I switch the first and the last, and I switch the sign of the first two. So this right here is going to be 1 over AD is 12. So 1 over 12 minus 2 times negative 3, negative 4 switch, and the 2 and the 1 stay, but they become opposites. So this is actually 1 over 10. So I get negative 3 tenths, 2 tenths, which is 1/5, 1 tenth, and negative 4 tenths, which is -2/5. So always reduce your fractions and watch out for stuff like that. But that is our final answer for that problem. And for the next one, we want to do the same approach. So this is going to be equal to 1 over -9 times -11 is 99, minus -4 times -2 is 8. So the determinant of that matrix would be 91. Over, we switch the -11 and the -9, and then we make this a +4 and make this a +2. So then 91 being relatively prime for all these is going to be nice. So we get -11 over 91, 4 over 91, 2 over 91, and -9 over 91. And that's our answer there. So, inverses, determinants, scalar multiplication, addition, subtraction. These are all things you should be able to work out by hand without a calculator, but definitely use a calculator to check. So make sure you review using a calculator. Now, if we want to practice using a calculator, we can look at finding the inverses of 3 by 3 matrices, because this is not something I require you to do by hand. So we're going to bring in our calculator to do this. So all we have to do is go to the matrix menu, and we're going to go over to edit our first matrix. So it's a 3 by 3 matrix, so I put that in as such. So we're going to get a 2, 5, 4, 1, 2, 5, -3, 3, -2. So there are all of our values. Now just really quickly, just read over these values to make sure you've typed everything in. Most of the mistakes I see are from people accidentally putting in a +2 instead of a -2. So I say that, and I'll probably make the same mistake. So here we get matrix A, and all I got to do to find the inverse is just give it a -1 exponent. Ooh, now that's ugly. So what we can do is actually go to math, fraction. That's going to make everything this beautiful, nice fraction. So copying down these answers will give us our answer. So I'm going to copy these down real quick. So our calculator tells us this is 19 over 67, -22 over 67, -17 over 67, 13 over 67, -8 over 67, 6 over 67, -9 over 67, 21 over 67, and 1 over 67. So rather big with our fractions there. Okay, so that's exactly what I got from my calculator. All right, we're going to do the same thing, but we're going to do that with number 14 here. So I'm going to go back to edit, and I'm actually going to type over this, which I don't recommend you do, but do as I say, not as I do. So I plug in these values here. And I'm just going to read over. So -1, 3, -1, -2, 2, -3, 0, 3, 0, to make sure that everything is entered in correctly. Okay, and then I'm going to clear all this. And so I'm going to go back to my matrix menu, select that matrix A, and choose the inverse function. Here I get mostly integers, but some decimals, so yet again, I'm just going to choose math fraction so I can get some nice clean values. And there's my answer. So I'm going to copy these down onto my paper. So this is going to be equal to -3, 1, 7/3, 0, 0, 1/3, and 2, -1, -4/3. Whoops, a little wobbly there. But that's it. All right, now we want to do the same approach to solve systems of equations. So with these two, we can actually use substitution or elimination. But I'm going to set these up using our inverse matrices. And again, use a calculator to solve, to show you guys how to do that. So here we need the inverse of our matrix of coefficients. So that's 4, -6, 3, -8. And we're going to take the inverse there, and we're going to multiply that by our matrix of constants. So 0. Wow, just another 4. I can't write as a 4. It looks like a 9, this tablet. And that's going to be equal to our x and y. So then all I have to do is just really enter that into my calculator. So I'm going to clear out of all this, go back to my matrix menu. Matrix A, I'm going to make it 2 by 2 to be my coefficient matrix. So I'm going to get a 4, -6, 3, and a -8. That all looks good. So I'm going to quit out of this, go back to the matrix menu. I'm going to enter in matrix B now. Matrix B is going to be a 2 by 1. And so that's going to be a 0 and then a -14. Having this, I'm going to do matrix A to the -1st times matrix B, and I get 6 and 4. So that means that right here, I'm going to have, whoops, my x and y pair as 6, 4. It's an ugly 4, but we're going to leave it like that. For the next one, 16, I'm going to set up the same way. So this is going to be 20, 50, 12, 30 to the -1, and I'm going to multiply all this by 7, 0, and that's going to equal x and y. So I think I lost my calculator here, so there it is. Right, it's going to clear out that, go back to my matrix menu and retype these matrices. So go back over to edit, 2 by 2, so we get 20, 50, 12, and 30. Hooray, yeah, looks good. Quit out, go back to the matrix. Now I'm going to enter my solutions, my matrix of constants. So that is a 7 and a poorly written 0. So now if I actually type in that same value, uh-oh, what happened here? Actually, I think I mistyped something. Oh, no, actually, I didn't. So what actually happened here was we can check this out by looking at the determinant of matrix A. It's 0. Notice, 20 times 30 is 600, minus 50 times 12, well, 5 times 12 is 60, with another 0, 600. So this is 0. And so if we want to find the determinant of this, it's 0. So the inverse is 1 over 0. Ooh, that's a little bit nasty for that, isn't it? So actually, using this is a little bit more of a challenge for us. So instead, what we could do is use our substitution or elimination to figure out if we're going to have no solution or infinitely many solutions. So just looking at this, let's see, I could divide by 3. So I can divide this second one by 3. So if I divide this by 3, I'm going to get 4x plus 10y is equal to 0. And then I can multiply that all by 5 to get 20x, or negative 5 to get negative 20x minus 50y is equal to 0. I could have just multiplied by 5/3, but I broke it up into steps to really show where this comes from. So 20x plus 50y is equal to 7. So notice these are opposite. So if I add, I get 0 is equal to 7 plus 0 is 7. Well, when is 0 equal to 7? Never. Never, so there's no solution. And it helps if we spell solution correctly. So there's no solution. So watch out for that. You know, if you have a determinant of 0, it could be infinitely many solutions or no solutions. So, you know, fall back to substitution or elimination to figure it out. But I'm going to use the same setup for over here for number 17. But yeah, let's do that. So I'm going to write out what these matrices are. So I'm going to have, this is going to be 3, 5, -1, -2, 6, -1, and then 3, -2, 1. The inverse of that times -24, -29, and 9. And that's going to be equal to, well, in this case, STR. Helps if I know my alphabet, right? RST is equal to this. So there we go. So just putting this into the calculator now. So let's do that. So go back to my matrix menu. We're going to go over to edit that first matrix. And so that's a 3 by 3 matrix. Oops, 3 by 3. And so plugging these values, so we're going to get a 3, 5, -1. This is going to be a -2, 6, -1, 3, -2, 1. Okay, so 3, 5, -1, -2, 6, -1, 3, -2, 1. Great. Cancel. Clear all that. Go back to my matrix menu to enter in that second matrix, matrix B. This time it's a 3 by 1. So we get -24, -29, 9. Quit this out. And I'm going to pull up my matrices. I'm going to do the inverse of matrix A times matrix B. 0, -5, -1. So I get is my solution. I can write this as an order triple. So 0, -5, -1. Simple enough. For the next one, I'm going to have ABC is equal to, this is 1, 3, 5, 5, 5, -4. I was so happy about writing a 4 correctly for the last problem. -4, -2, -4, -5. Take the inverse of that and multiply that by the matrix of constants. So 22, 3, -25. It's painful to be saying some number and trying to write another number. All right, so let's type that all into the calculator. So I hope that you're seeing with these that these are more tedious than anything else. So hopefully you're just kind of skipping over this and nobody's really listening to this dialogue of me typing this into the calculator, because I can imagine that this is not the most entertaining. Don't forget the PDF copy of these answers is up on the website. It's probably easier to take a look at all that as opposed to sitting through me sitting here typing these values into a calculator. Okay, I think we have this. So 22, 3, negative 25. And so we're going to type this into our handy-dandy calculator. So the inverse of matrix A times matrix B spits out 1, 2, 3. Hey, look at that. Look at that. So what do we get for ABC? Oh, I don't know. It's easy as 1, 2, 3. All right, so make sure that you're aware of how to use this with the calculator. For the systems here, for 17 and 18, for systems with 3 variables, you're more than welcome to use substitution or elimination, but those are very time-consuming processes. For these problems, this is as much work as I would expect to see on the exam. So by all means, just show this, and that's perfectly fine. And you can see that it's tedious, but it's a lot quicker than solving this by substitution or elimination. All right, well, that was all Unit D material, all matrices. Now, Unit E, we talked about sequences, so geometric sequences. So we want to find out if these are geometric sequences or not. The geometric sequence is when we are multiplying by a common number. So here, because we're multiplying by -6 each time, we get that the common ratio is equal to -6. The explicit formula for this is going to be that the 10th term is equal to the a sub nth term is equal to the first term times that common ratio, so times -6 to the n minus 1 power. So if we want to find the 8th term, this is 1 times -6 to the 7th. So why don't we use our calculator again for that? We have it here anyway. So this is 1 times a -6 to the 7th power. So -279936. So -279936. It asks for the common ratio, the 8th term, and the explicit formula. So that's the answers for all these. So please make sure that you do answer all the questions that it does ask. Okay, next up, we have this. So times 5 times 5 times 5. So yep, this is a geometric sequence. The common ratio is 5. The explicit formula is the first term, which is 3, times 5 to the n minus first power. And so if we want to find the 8th term, that's going to be 3 times 5 to the 7th. So we can do 3 times 5 to the 7th, which is 234,375. So 234,375. Okay, so there is the nth term, the explicit formula, the common ratio, and our 8th term. Evaluate, so this is basically asking find the sum. So we want to find the sum of these. Well, the sum of, so this is the 8th term, is equal to the first term, so -4, times 1 minus r to the nth power divided by 1 minus r. So we can just plug that all into the formula. Watch out for parentheses with this one. So this is going to be, get rid of all this other stuff. So negative 4 times parentheses. I'm going to put another set of parentheses. 1 minus 3 to the 8th divided by parentheses 1 minus 3. Close those parentheses, close the other parentheses. And so I should get negative 13, 120. So negative 13, 120. And that is our sum. Here, we're going to have the sum of these 7 terms is equal to the first term times 1 minus the ratio, which is a negative 5 to the 7th. And this is all over 1 minus a negative 5. So we can evaluate this in the very same calculator. So we're going to get 1 times parentheses. I'm going to put this 1 minus parentheses negative 5 to the 7th. That's my numerator. I'm going to close that in parentheses. Divide that by my denominator of 1 minus a negative 5. Close parentheses for the denominator and the overall process. And 13,021. And that's my sum for those. Okay. Next up, we want to do the same process, but for arithmetic sequences. Exciting. So, we want to figure out if these are arithmetic or not. Do the same process. So here, am I adding something? Yeah, I'm adding 200 each time. So here the common difference is actually 200. The explicit formula is the first term, which is 19, plus n minus 1 times d. But we don't leave it like this, so we have to distribute this in. So we get, well, I'll do it down here. So 19 plus 200n minus 200. So we're going to have 19 minus 200. So this, oops. This gives us that a sub n is equal to 200n minus, well, minus 200 plus 19 is going to be 181. And if I want to find the 52nd term, all we got to do is plug in 52 for that. So get my calculator there, which I accidentally closed down. So we're going to do 200 times 52 minus 181. And we get that the sum, or sorry, the 52nd term is 10,219. So 10,219. There's the 52nd term. There's the explicit formula, and there is the common difference. We'll do the same approach here. So we are actually adding 100 each time. So the common difference here is a 100 as opposed to a 200. The explicit formula is going to be a negative 10 plus n minus 1 times 100. So this is negative 10 plus 100 minus 100. What? 100n minus 100. So a sub n is equal to 100n minus 110. So the 52nd term is, we just have to plug in 52 for there. So that's 5,200 minus 110. So that's going to be 5,090. So there's our 52nd term. There's our explicit formula and our common difference. To find the sum, it's hopefully simple. The sum of here, we have these 20 terms. That's going to be equal to 20 divided by 2 times the first term plus the last term. So this is 10 times, this is going to be a negative 161. So we just have to multiply by 10. So we get negative 161 times 10 is that. And so here we have the sum of these 5 terms is equal to 5 over 2 times 17 plus 33. So this is going to be 50. So if we think about it like this, 5 halves times 50, we can cross reduce, right? This is actually 5 times 25. So the sum of these 5 terms is going to be 125. Okay. Well, boy, that was a lot. I think this is more tedious. So Unit E, there are only a few questions here, but we just did this, so hopefully it's fresh in your mind. Plenty of practice that we've done, plenty of worksheets, and same with Unit D. So make sure that you review all of this material so that you can do well. And that's it for the midterm exam review. So those cover all the units on the midterm exam. So good luck, and let me know if you have any questions.